there's my natural log of x, which crosses the x-axis at x equals 1. That tells me that these lines y equals 1 and y equals 2 are somewhere up here. So maybe we'll draw them in as y equals 1, y equals 2. And x equals 0 is the secret name of the y-axis. So we've already got that piece done. The part of the graph that we are then interested in revolving around the y-axis is this region in here. I'm always drawing my cross sections perpendicular to the axis of rotation. And then setting our radius to go from the axis of rotation out until I hit the function. But this distance here, it's not a y distance. That distance is an x value, which means I know that I'm going to need to change my function to actually look like x equals e raised to the y. Putting that together, and again, because I'm doing this as a volume of revolution, and one edge of my cross sections will always be touching the axis of rotation, I'm going to have that the volume is pi r squared dy. And there's my little bit of dy for the thickness of that cross section. Add them up calculus style. So our volume, we're going to take these cross sections down as far as y equals 1 and up as far as y equals 2. And our radius function, because it's that x distance, x is equal to e to the y, which is going to make this e to the y for our radius squared dy. Again, if the question just asks us to set up for the volume, we would quit here. Let's actually finish it off. And for me, when I look at this, again, I'm going to ask myself, algebra, trig, or a mixture of stuff? It's a mixture problem because we have e to the y. So I might instinctively be thinking about a u substitution. But the derivative of e to the y is e to the y, and I don't have another one sitting in there. Instead, I'm going to look at that e to the y squared, and remember that that's interchangeable notation-wise with saying e to the 2y. And in some problems, I have to take an e to the 2y and write it like this. But in this case, I'm going to take my e to the y squared and rewrite it like this, because this we know the antiderivative of. When I integrate that, I'll end up with e to the 2y, but I have to correct for that chain rule that would happen by multiplying by a 1/2 out in front. And we're taking that from 1 to 2. So plugging that in, I've got pi over 2 e. When I plug in a 2, I'll have e to the 4th. And when I plug in that 1, I'll have e squared. And that's about as far as we can take that one.